All right, hello everybody and welcome to the Dedicated Show. Today we have a fun topic ahead of us and it involves gloves, right? Cleaning gloves, but why? We're actually going to talk about cleaning data for effective data science. So I'm not going to wear these gloves the whole time, but it was just for dramatic introductory purposes. Our guest with us today is David Mertz. He is actually a partner and senior trainer at KDM Training, and he's also the author of this cool new book, Cleaning Data for Effective Data Science. It's essentially doing the other 80% of the work with Python, R, and command line tools from Pact. Really, really excited to have him on our show today. As you're getting started, let me know in the comments, what percent of your time do you spend actually cleaning data, right? So if you're a data analyst, data scientist, whatever role you have, even if you're a student learning data science, just comment around, is it 80%? Is it more than 80%? Is it less than 80% of your time that you spend actually cleaning data before you get to analyze your data, visualize it, or do whatever it is you need to do with it? All right, at this point, I'm going to go ahead and bring up David Mertz. Hello, welcome to the show.
Thank you so much, Kate.
I see you don't have your gloves on, which is okay.
I didn't get the gloves now.
You do data, you do cleaning in a different way, which we're definitely going to talk about. Before we get into the topic and before we talk about the giveaway, I do want to give you the opportunity to introduce yourself and tell the audience a little bit about yourself.
Thank you so much. Well, I have sort of a diverse background. Wanting to write this book and moving into this area or becoming a data scientist has been something of a winding path. I actually have my doctorate in a completely unrelated area of political philosophy, sort of post-structuralist odd stuff that technical people don't know. You probably can't read titles behind me, but it's sort of a mixture, half and half, of books and journals that are that very old background I had, which was delightful, and the things that I do in the last several decades. But over the course of that, I figured out after a number of years that people don't actually pay you to know about French post-structuralist Marxist philosophy. So they do actually pay you to write computer programs, which is nice. So I did that sort of thing for a while, but in particular, I moved into focusing on a couple things. One is I became very involved in the Python community pretty early on, like in the end of the 90s, beginning of 2000s or something. And for a number of years, I wrote about that in a variety of places, but in particular for a site called IBM Developer Works, which still exists, but it doesn't quite have the open source and community mission, I think, as it did back then. Anyway, so I wrote a column for many years called Charming Python, which was it was the most widely read source about Python for 7-8 years, something like that. So it was nice to have that relationship with the community, and back when you could go to conferences and interact in person with people, I have so many wonderful connections in that community. But then kind of from there, I really, somewhat by accidental opportunities, but really had an opportunity to move into working with scientific and numeric computing, which over roughly the same time frame, sort of later 2000s into the 2010s, I think Python has really become a dominant player in that. But certainly, and in the book, I have examples in R and in command line tools as well. And definitely the statistician angle of that is probably the R world, but Python seems to be most other things. But anyway, so I moved into working with scientific and numeric computing, as I say, including having a wonderful opportunity for a number of years to work with folks who have built the world's fastest supercomputer for doing molecular dynamics, which is just remarkable stuff. I mean, it's custom silicon and it's 1,000 times faster than the next best supercomputer if what you're doing is protein folding. So that was a wonderful little episode in my life. But then from there, it's quite a diversity of things, and there's consulting, kinds of organizations, companies over, scattered throughout that. But I, at some point in, I don't know the years, the 2010s, moved into developing the training program for Anaconda Inc., which was called Continuum Analytics, which is one of the sort of premier, maybe small players, but in open source communities and Python and scientific computing, which then very much shades into machine learning and data science. Kind of the language changes while I'm doing this stuff. I mean, there's been a lot of these, a lot of its nomenclature changes, but a lot of it's driven, of course, by actual technology changes as well. For example, the mathematics of a lot of deep neural networks were available decades and decades ago, but GPUs that could actually make it do something weren't available before 5, maybe 7 or 8 years ago. It's a fairly recent thing in terms of that area. Anyway, then since then, I was for a little while, for a year, a CTO of a little teeny company that was in machine learning, really, which meant I was a data scientist. I mean, it was like 6 developers I worked with, so it was CTO just is a fancier way of saying that I was the data scientist who made models.
Right.
But so in this variety of consulting and employment sort of positions, I had actually an opportunity to look at a lot of data that come from a lot of different sources, in many different formats. Sometimes for the point of view of machine learning modeling kind of things, including years the deep neural network kind of things, but also just kind of classical models, linear regressions and k-neighbors and gradient boosted trees and things along those lines. And I'm sure many other people who are in the audience here have dealt with this diversity of data that comes from all different kinds of clients or sources or different kinds of instruments. And what we find, I mean, what I find, but everybody else I hear speak says the same thing, is that the data is always dirty. No matter what the source, no matter how pridefully the providers of it boast of the quality of their data, no matter how careful the curation process that was involved, data that you get that you actually want to work with from this perspective of machine learning or of effective visualization or simply of sort of statistics or data analysis of it, always has a lot of problems.
Right.
And what you have is every single book about some new sexy library for dealing with these things, especially in the sort of machine learning space, but kind of equally with visualization, has a sort of throwaway chapter. So you read the newest book on TensorFlow, which is wonderful library, it's powerful things. And and there's probably 20 books on that topic. And you read and some of them are very well written. I'm not at all critical of them, but they have an appendix or a preface or one sort of throwaway chapter that says, well, you have to worry about cleaning up your data before you do these techniques that are really interesting.
Honestly, my course, I have a course on data storytelling, and there's a line in there that says, I'm assuming all the data is clean that you're working with, which I know is a terrible assumption because almost none of the data, as you said, that is valuable is actually going to be perfect and clean for you. But I think this is why your book comes into the world at such a good time, right? Because we're assuming that the data will be clean or the technology is going to help us keep the data clean. But you go on to say that the data is always dirty, especially the one that you actually want to use. And I definitely want to talk about all of that. First, I do want to refer, there have been some responses to our earlier question in terms of how much time people spend actually cleaning data. So here we've got 40%. We have Chad said 60%. Ravit's here. He said 30 to 40%. Shruti says she finds cleaning is the most important and decides how to further her project. So really excited to talk about all of this. And I also noticed several of you have caught on to the hashtag pact. I'll briefly introduce this. We're doing a giveaway towards the end of our session, so I definitely encourage you to stick around. We're giving away two print copies of David's new book. And in order to basically enter the raffle, all you have to do from either LinkedIn, Twitter, Facebook, or YouTube is wherever you're watching this show from, just put the hashtag pact. It's in the little scrolling thing at the bottom as well. It's PACKT. And if you do that hashtag, it automatically enters you into a raffle, and we're going to share screen and we're going to show you kind of who the winners are. We'll select winners towards the end of the session. It's a lot of fun. I do see we have 8 entries so far, so guys, keep them coming. We're going to select 2 winners. But David, we actually already have a question for you here from Scott Taylor. He says he hasn't read your book yet, but how much of your advice in the book is around fixing duplicates, hierarchies, taxonomies, and geographies?
Quite a bit. I mean, the way that I arrange I'm not sure I can say a percentage. I guess I can. I actually have a copy myself, so I can look at the table of contents to remind myself. But deduplication is certainly a very important thing, and it's also somewhat more subtle. I mean, if you find you have data that has literal duplicates, that's straightforward to remove. But very often you have representations that are effectively the same data, but they aren't, byte for byte identical. There's some numeric differences or some differences in the missing values of various features that, accompany something that's in some sense you think likely to represent the same observation. So then it can, of course, become much more subtle than that. I mean, potentially you can use things like clustering techniques to try to identify this near identity. I don't really go into that. I mentioned it in passing, but the sort of ordinary mechanics of using things like data frames to do, deduplication, as well as many other kinds of operations, is really throughout the book. I use pandas a lot. I use R and the tidyverse and Tibbles to a lesser degree, but I want to illustrate those things. So there's not that much on geography specifically. There maybe could be more on GIS. But in particular, there's one particular chapter where I look at, there's sort of, there's a narrative, I'm sort of stammering here, but there's kind of a narrative that goes through the book for people who haven't seen it, that I really, in a way, want to present sort of the journey of a data scientist as we go through the process from, acquiring the data. It's been uploaded to us from a client to the various sort of stages of processing of it, where at one level we're interested in the actual formats that it comes in. And there's a variety of concerns that are specific to that, whether it's, provided in an SQL database, or whether it's provided in HDF5 files, or whether it's provided in JSON files, or other kinds of, actual physical representations of the data that we encounter. Right. But then we want to look at sort of the individualistic problems. There's one particular row of data that can be identified as a problem in some way. And so probably the question that just came up really pertains to that chapter mostly, in the sense that, this is an isolated problem. There's something wrong with this particular observation. The instrument went wrong, or the transcription between formats went wrong, or some other kind of error along those lines. Right. But then you get into things that are more systematic problems. Maybe duplication is more systematic. It sort of depends what you think is the root cause of it. But where you actually analyze whole data sets to look for things like bias and systematic distortions that you might be able to identify inside of it, using typically statistical tests on the data, things like z-scores and interquartile ranges and things like that, where again you flag particular data as suspect, at least, and I do make a point, I hope, to emphasize throughout this the importance of versioning data, it's very easy when you walk through this journey that I'm describing of thinking that the particular assumption you make at some particular point in your processing must be correct. And so therefore, it's okay. You can throw away the old one. I know what I have now is better, but that's the wrong approach. You want to be able to retrace your steps because you may have gone wrong.
Yeah.
But then from there, after you've done this sort of analysis of, the individual rows or the individual data points that are suspect, and then after you've done this analysis of what might be systematic about distortions in your data from bias or other causes, then you want to look at remediation of it. And remediation sort of recapitulates these two prior steps that I just mentioned, in the sense that one kind of remediation is simply imputing individual values. That, there's either this particular, data cell that came in was missing when you got it, or you decided in one of these prior analyses that it was unreliable. And so you want to make it a missing value by, zeroing it out or, putting in a null value or the equivalent.
Right.
Maybe you want to go back and re-impute some value that you think is characteristic of that data, because that's going to enable better visualization or machine learning or other kind of techniques. But then the final part I discuss is feature engineering, where it sort of gets a little past the cleaning data per se into the machine learning-ish as such. But this is where you kind of go systematic, in much the way that in the prior pair of chapters, I look both at problems with individual rows and then problems that affect whole data sets. Here, I look also at imputing values to individual rows, and then in a sense, imputing values to entire data sets. Like you develop synthetic features. You say that, this wasn't directly in the measurements, but you can extrapolate from that there's some other, combined measurement that might be more useful. These synthetic features. And then after you've done this journey, you've read the 500 pages of my book, and you've sort of replicated these steps in your own data set that you've obtained for your particular business purpose, then you're ready to do the, pick up TensorFlow and pick up Chainer and pick up scikit-learn and do the fun things with it.
Yeah, absolutely. And I just had to check. You said 500 pages. It's 463. Okay, proper data. So I just confirmed. You rounded up. Shruti has a question here about your book, and I actually wanted to share my screen because I know you got a really cool landing page for your book. So I'm going to pop that on. But her question is, what was the most fun or specific topic that you found interested while working on the book? And maybe tell the audience a little bit about what they can find on this landing page here.
Yeah, so let me talk about the landing page first, then get back to the question that was raised. So I hope this page will be useful for you. I've tried to put everything here in a fairly attractive style that you might want to know about the book and a little bit about me. It's a little subtle, but at the top, those are actually links to my little personal consulting business, KDM, and to my email address. So if you hover over, they're highlighted, or you can just copy the address too. But in this page, you can actually read most of the book online. There's bits of it that I've marked as, go buy the book, and I have advertisements throughout. But I want to let you get a sense of what's in here. So the little navigation button, the what do you call hamburger icon, the 3 bars that are over at the left, you can take a look at the different chapters, and then much of the material within those various chapters is going to be available. If you're using a small device, it's going to just give you a little warning that says, which is whatever limitation, but it doesn't exist in the paper book if you go by that.
Yes.
But let me return to the question of what was most fun. And this may be influenced just by, there's a lot of parts that are really fun to think about. And it was sort of funny as I wrote the book that I would, need data set examples. Many of these are things that I, could obtain from various public domain sources, such as government sources, because those are going to be freely usable.
Right.
Some of them were ones I made up in various ways, but that I thought were characteristic of things that I've really worked with. But there's this kind of perverse delight I get as author of this particular book, where I find a data set that I can identify problems with, especially if it's, maybe it's a large data set and I sort of, figure out where the problems are, and I get a certain, to perverse joy in the fact that, oh my gosh, I've identified why this is a problem, because now I can use it as a good example in my book to write about. But this, and you don't get the same joy when you're actually trying to do your business purpose to work with the data.
Right.
But you do have to go through that process nonetheless, regardless of what your particular affect related to it is. But this is true even in like well-established, like there's a variety of data sets that are, kind of stock examples when you teach courses or you test out a new library or something in machine learning or in visualization or other areas. Things like the iris data set. That's a small, historical, very important one. Or the Wisconsin breast cancer set is another similar sort of
What about Titanic? The Titanic data set? Titanic? I keep hearing about that one.
Oh, yeah, the Titanic one. That's big too. Although that one is, that's in a way too easy. So you look at these data sets that are, thousands and thousands of, probably millions of people have looked at them, but like thousands of courses and books and articles and stuff have been written about these.
Yeah.
And you pick up any one of these, even if it's fairly small, like the Titanic set, which is a few thousand rows, and you find that they're not clean data. And thousands and thousands, millions of people have looked at these, and they're still dirty data. There's still problems in these data sets that are famous and well studied. Which, I shouldn't be smiling so much. I should be frowning about this. Although, okay, this is good.
Don't be so excited. Come on, David.
But it's sort of, it goes deep. It's impossible for any kind of aggregation of data not to have problems.
Right.
Maybe not impossible, but it's
rare.
very uncommon to encounter even a moderate-sized data set that doesn't have at least some problems.
Yeah.
But all of this, I think, is not an answer to the question. And the answer I'd like to give is the one that you and I were discussing just before this started, is there's a pretty brief section that I have where I discuss character encoding issues. And if you're dealing with like natural language texts, which is not obviously the only kind of data you deal with, but it is one, there are a variety of sort of legacy, but they exist, problems that occur with, there's confusion about how characters were encoded in, words and human languages. And so I get to write for a few pages in the book about something called mojibaki. I'm not sure if people know that word, but it's apparently Japanese for just something like wrong character. But but basically it's this idea where there's a misunderstanding somewhere in the transcription process or the data analysis process, where you think that it's being represented in a certain way, the natural language, and it's actually different. And sometimes it produces these very comical effects. I guess especially in the CJK languages, which unfortunately I don't read, but there were a number of competing standards, like in Japanese for a number of years, where the word comes from, where one particular encoding of Japanese characters, would represent various Japanese characters, but in a different manner than other encodings. So very often you would read in assuming one particular kind of encoding, and it would produce Japanese characters, but ones that were completely nonsensical and sort of humorous and, almost these, like a word game or something, where it would be sort of comical in the juxtaposition of these characters to each other that, don't really form sentences or meanings. But I show some examples of that using a variety of different human languages.
I have the pages open. I don't know if people can
the,
see it.
The Chinese and the Russian and stuff like that.
Yeah, the Chinese and the Russian.
Yeah, so I get to do, the Chinese examples I give, I just have to sort of personally, naively, copy them. Like there's some segment of a Wikipedia article on character encoding that I use as an example, but then it is encoded in various ways that may not be interpreted quite right.
Mm-hmm.
But I do similar things with things like Norwegian and Greek and Cyrillic, Russian, which I read the characters of, and you can see how they can go amusingly wrong when you're on something. And so even though my examples are presented in a way to hopefully be sort of lighthearted and it's very obvious what's gone wrong. In fact, This is a much thornier problem that you get to in real data you encounter. And it's not always uniform. I mean, you have, for example, in a database, human names or or like business names or, addresses or short text descriptions or whatever of particular entities that are described in human language words and characters. And you make certain assumptions in the processing of them where you get this Mojibaki effect and you get, things that don't make sense in terms of the characters are output. And there's techniques to go to try to figure out what's going on. But I mentioned database in particular because in a actual text file, hopefully, usually within the file, at least it's all the same encoding. Although that kind of assumption can be violated in cases where things get, concatenated. But something like a database, you're not always even safe in that assumption. I mean, from row to row, you may have different kind of encoding issues that popped up over time.
Right. And I was just looking
at a world where everything is encoded always as UTF-8 and nothing else ever happens and everything's easy. But in my vision.
I was just looking, we had several questions about the link of that screen that we were just sharing. So I've actually shared the link in the comments, and you can also find it in the description, at least on LinkedIn, for those who want to go ahead and check out the landing page for that book and maybe start reading parts of it before you get a copy. We had another question here, David, from Nino. The question is, can we read about treating outliers in the book? Do you cover outliers?
Absolutely. That's that's basically the focus of one particular chapter, the one that I call data quality, which I sort of mention these, movements or whatever, if you think of it as a symphony, within the book, where I sort of first treat, individual problems, then I treat more systematic problems, and then I remediate individual and then more systematic problems, just to make a simple characterization. And the treating more systematic problems is not entirely, but largely looking for outliers. And some of that's very simple. I mean, you think about things like Z-score, which people are maybe familiar with, depending on exactly their background. But basically, you're looking for things that are statistically unlikely to be real values. There's more subtle considerations because you have expectations about the distribution of data and things like that, where different kinds of assumptions come in. But, I give a variety of examples and discuss this. And another technique called interquartile range is similarly important. But I think the thing that a lot of people don't, so yes, please read that chapter. And I think you can even read the online version to get most of there might be a couple little subsections I've marked out as not available unless you buy it, but most of it you can read at that landing page. But I think that dealing with outliers at the level of in a particular column of data or a particular feature where you can have, things that are merely statistically unlikely. They're not the kind of characteristic value you expect of that kind of data. But then you often get interaction effects which I think a lot of data analysts or data scientists don't probe into as deeply. And I give some examples where I hope that is illustrated, where particular individual values aren't necessarily in themselves implausible, but particular kinds of interactions of those values become statistically improbable.
Mm-hmm.
And I think that's a very important thing to look at. And unfortunately, I don't know that there is or really even can be a completely automated or systematic way to do that. I think really having a feel for the domain you're working in is enormously important when you do work as a data engineer or data scientist, to figure out which particular kinds of, in a way, synthetic features, but particular combinations of measurements within an observation are likely to be particularly poignant in your consideration.
Right. And we had a question here that takes us to the beginning of the process. So we're talking about maybe already dealing with data after we've collected it, but any suggestions here for Scott Taylor, who's asking, how do you work with data management teams to make sure you can start with not clean data, right? Because that seems to not exist, but to start with cleaner data. What recommendations do you have there?
This is very much a social question more than a technical question, I feel like. I'm not sure if that was the intent of Scott who asked it. Sorry, it was Scott, right? But whatever, the questioner. It really depends on your relationship with the data management teams. I mean, depending on your work context or your research context, you can have all kinds of different relationships. In some cases, it's just, this is the data you receive from an external client. And in that case, honestly, there's probably, you can recommend better practices to them, but, depending on the nature of that relationship and who's trying to get what out of it, your recommendations may or may not be effective. But assuming you're talking more in-house and you actually have a kind of collaborative relationship with the people who are in the data management department, some of the audience here probably are the people in that department, so I don't want to just be speaking past them. But assuming you're more in the data science team or this more analytic team rather than the sort of core data infrastructure management team, but you do have a good working relationship, I think proposing measures for a kind of, a periodic, automated to the degree possible review of data quality can be an important structural process. And, you can use the kinds of tests, statistical tests, and other kinds of analytic techniques that I talk about. Even if you don't have a particular analytic purpose or a particular modeling purpose in mind at this moment, the kind of quality analysis techniques are still applicable. To a somewhat lesser extent, because many of the questions you want to ask are driven by your ultimate purpose.
Right.
You're trying to get out of this. But there's a lot of questions like outliers that was mentioned in the last question, where if there are extreme outliers, probably something's going wrong in your data collection or transcription process. And if it's possible for the data management team to, as part of their own processes, run tools that look for these occurring, and that can be a flag that something's gone wrong in this process.
Right.
And in fact, it can, hopefully remediate it in the future. You have some particular data collection technique or some particular instrument or whatever it is that's you can identify as frequently producing unreasonable values. Well, that's a chance to go back and adjust that manner of data collection. Yeah,
and just wanted to make notice. So I know we have probably about 10-15 minutes left for us to chat, and we have so many questions that came in. I'm trying to take as many of them as possible, but quick reminder to the audience, we are giving away 2 copies of David's book today. So We have over 20 entries already for those who are getting into the raffle. All you have to do to participate is type in the word #packed in the comments from any of the streams that you have joined. So David, let's try to take as many questions as we can here. If you're open, we've got one here from Kovani, who's asking, how do you handle legacy data cleaning activities which are built in the systems, a long time ago?
Well, I mean, so I guess there's a different couple aspects to that. If it's a question of modifying, I mean, the question here is whether it's static data. It's, the stuff that exists on disk somewhere, in a database or in a flat file or whatever. And it just simply, came into existence a long time ago. That's maybe a different question than if you have ongoing processes that rely on old code that, keeps acquiring new data, but it's based on this old code.
Right.
I mean, if it's the static question, it's just, I have these historical records, but maybe there's problems with them. Mm-hmm. It hopefully can become a one-time data migration effort. You do the kinds of analyses that I talk about, and maybe ones that I didn't even think of, but you do analyses of the legacy or the historical data that was collected in whatever way that was perhaps not entirely reliable, and don't throw it away because, maybe your assumptions about your cleaning processes are going to be wrong, but, make copies and make versions of it that reflect your assumptions about how to make it, better data. Mm-hmm. And then, from that point forward, generally rely on the processed, the scrub data. Now, if it's an ongoing system, it becomes more complicated. I mean, obviously, many, installed software bases can be very large and very complicated and very intertwined with other, critical operations that you want to do. So even if you can identify something that's likely to be problematic in the code base and the way the data is collected or aggregated, it's not necessarily easy to touch that code because it can have other effects. I mean, one approach is to sort of layer things, which introduces its own complications. I mean, it's really getting to a software engineering question more than a data question per se, but where you do something like I described a few moments ago in terms of the analysis and remediation of the legacy data, the historic data, but you do it with data that may continue to be aggregated, on a current basis, but you nonetheless state that new data comes in a perhaps unreliable way, and it goes through the scrubbing process to get to the sort of, separate container where the hopefully cleaner data now lives. But of course, that introduces yet more layers to the process, and potentially, need for computer resources to do the transformations and the analysis and things like that, and twice as much storage space and a variety of things. Mm-hmm. Obviously, if you can re-engineer the entire collection process and make it more modular.
I was just going to say, throw out the legacy systems, right, and start over with all the modern technology.
Yeah, but I mean, if your day-to-day business is being run by this stuff that's there's problems with, but you don't want to shut down your business, But again, I mean, this is a software engineering problem, which is very important, but it's almost the software engineering problem, whether or not it pertains to data collection per se. Mm-hmm. Software systems are big and well established, and you never have enough there's a lot of technical debt, and you never have the resources to just start over. I mean,
most companies don't. Right. So, okay, we've got a question here about the book, and I'm actually really looking forward to hearing what you've got to say, because that's sort of me here. I'm also not a data scientist. So Katya's asking, if you're working with data, but you're not necessarily a data scientist, will this book help, especially if she's currently not using Python or R?
I don't know if it's possible to get more of an answer, but I mean, I try to present concepts in the book. I mean, I give examples in Python and R, and there's a fair amount of code, but I try to keep it fairly short. And, there's a few cases where I maybe do more code than I strictly need to, but basically there's a bunch of code that's stashed in the archive for the book, and you can go get that and download that. There's nothing, it's all, public domain. You're welcome to it. But basically I try to present conceptual elements of the various processes that I recommend. So there's source code that does it, whether it's Python or R, occasionally, command line tools. But they're, replicatable steps that I want to talk about the motivation for why you want to do this particular step, and present the code just as a way of illustrating the underlying concept of what you want to do. So, I mean, I think that you're going to have to make a little bit of sense of a little bit of Python or some R code. You don't have to necessarily be at a level where you can write it yourself, but it is a way of expressing more rigorously the kinds of steps that you would want to perform than you could do just in English prose or some other language prose.
All right.
A colleague and friend of mine who's a very, brilliant, I mean, insanely brilliant and esteemed in Python and other communities is a fellow named Alex Martelli. Anybody who's in the Python community has heard his name. And he wrote a very kind review of my book, but in it, he chastised me for putting data science in the title of it, because he doesn't like that word. He wants to describe what we do as data engineers, which is perhaps closer to the questioner. I don't know exactly what her role is, but and he feels like that's one of these hype words, and I think because he has an attachment to science, and
okay, yeah, there are definitely people out there who don't want that term used.
I don't necessarily share his particular sentiment there, but I think it's notable, not being who he is, at least. I mean, but it does, there's a truth underneath that a lot of what we do in any kind of data science is always engineering. I mean, data engineering, it's always looking at the sort of messy details, not just messy in the data, but the messy details of the processes involved. And it's not always, I mean, it's very rarely a small part of even what the most abstract practitioners do is the really abstract stuff. I mean, that's true if you work in a physics lab or a biology lab too. You can work in a wet lab, think about genomics in a very abstract way, but when you're working with test tubes and sequencers and stuff, there's lots of messy details.
Yeah, obviously. So David, we're going to take one last question from the audience, and then we're going to go and do this fun raffle thing. If you do get a chance, later on, these comments and questions stay on LinkedIn and across the other platforms if you want to go in and answer more questions. But right now, the final question we'll take is around NoSQL. So non-relational databases are popular. Does the book cover NoSQL?
So I give some examples from MongoDB in particular. I give some sort of general characterization of graph databases as, and obviously there's other systems that are neither of those. Well, I mean, actually I talk about key value stores, which in some sense is an abstraction of a whole, like document databases are often largely sort of key value stores. And definitely I talk about those, and definitely there are characteristic problems that come with those that are different than those that you find in relational structures or more strictly tabular data. I mean, one very simple thing, and I possibly belabor that, but it really is an important topic, is representation of missingness. And inherently, if you have a non-tabular data, there's two ways that things can be missing. They can either simply not be in the hierarchy at all, or they can have some sort of sentinel value that indicates their missingness. Whereas if you think of tabular data, there's only one. I mean, it's always some sort of sentinel value that indicates missing, or
Right.
a collection of various values. But and maybe it means something different in this hierarchical or this document database context to be not there at all versus, you know, marked as not recorded or something like that.
Right.
And sometimes that kind of consideration really comes into how you want to think about the data.
Mm-hmm.
But more often than not, it's an artifact of what someone else quickly did in the collection process, and it doesn't really mean anything. This again pushes towards, you need to understand your domain. You need to I mean, your domain in the very abstract sense of like the scientific field or whatever, but also in the specific, like who acquired this data in what context and what were their goals at the time and what, you know, resources do they have available. And a lot of the answers change based on these histories.
Mm-hmm. All right, well, David, thank you so much for this. I'm going to go ahead and just share my screen for now. We're not choosing a winner just this second. For now, I will just let you know that we have 27 entries, and for those who are just joining us now, just type in the word #path in order to join the entries for the free bucks. As we give folks maybe another minute or two to get their entries in, David, I want to hear from you. And personally, I'm very, very interested in this because I'm writing a book right now as well. What was your most favorite part of writing the book and your least favorite part about writing the book?
Yeah, but there's a sort of mechanically noise in the background. I don't know if it was. Am I even not hearing it?
Yeah, what?
Okay, I'm having problems, but it may be specific to my system.
I hear you. It's fine. I see you. I don't know.
Well, it was. So I actually wrote the book primarily in the beginning part of 2020. So it's quite a while from the publication. And unfortunately, working with publishers is frustrating. I've done other books, and there's problems with it. And I actually switched publishers. Basically, almost completed text, which then had its own issues. Gosh, the echo is really terrible. If I try refreshing my connection, I know that's going to disconnect you for a second, but does that still work with the listeners?
Yeah, sure. If you want to hop off, it sounds like people are commenting that they're going to hop off and come back in, and you can do that. And for those of you that are watching, let me know if I'm producing echo as well, because maybe I'll have to do something and kind of hop back in. I do see David's. David, is that better, or should I try to hop off and hop back in?
It's far better. It may have been specific to my system. I hope it didn't apply to listeners as well. But
it sounds like some other folks are going and echo. But you mentioned to recap. So David had some issues with publishers who had already text type on publishers, which publishers later on, and that's kind of where we left off.
Oh my, I did get terrible again.
Really? Everyone is saying better now.
I may just turn.
If it's unclear, or like go ahead and edit the graph for now. I'm sure people might see that.
One more try. I'm going to try to reconnect. It's like an echo. I can barely understand what you're saying. I really apologize.
All right. So we've got 29 and let's see if we can put this at 30 entries. I just like round numbers. Then we're going to go ahead and hit the draw button. It's actually a really fun process where you'll see all your KPCs kind of scrolling by the site participation round, and then the winner will be announced. You can just see what's happening after that. David, any better?
Sadly, no. You're sort of robot with a lot of echo. The technologies of not getting to be in person like at conferences is frustrating.
Wait, it's my Wi-Fi. Let's see. Maybe it's my problem. All right.
If I'm audible again, is it okay for talking? Are you still there, Kate?
Hey, is this better?
No, but I'll just talk and try to ignore it. But I will say, in working with the publisher I got, one thing with Pat, one thing that I cannot be thankful enough for is I had the most amazing technical editor in the process, and I will call her up. Her name is Yuan. She's also in the acknowledgments for my book, and it was just I considered self-publishing. I have options with many different publishers. I didn't know her before that, but it was just so wonderful to have a technical editor who really understood what I was trying to get to, but from a technical perspective, but also from a kind of literary voice perspective. And if people look at my book, there's a lot of sort of clever allusions to other things and digressions and stuff. I don't describe technical content, but hopefully enjoyable as a literary product as well. And it was just so wonderful having an editor who understood all of that, and at the same time, made suggestions like, change this, change that, reword something, add this section, that were just spot on and positive and helpful. And it's so much better for having had such a nice technical editor. And also shout out to my friend and colleague, Mickey Tabeka, who is technical reviewer, who likewise provided some very helpful suggestions. You readers would not have had Benford's Law without Mickey, which is a nice little, it's a one-page section, but it's actually sort of an important section that I had not thought about before he recommended that. So I'm delighted that got added, and other important things that are thanks to him.
All right, great. Well, it seems like people are eager to get around here. So thank you so much for sharing your experience. I'm going to go ahead and hit the drop button so we can go ahead and see. We have 38. So good luck, everybody. Let's see. Hopefully you hear me. Not necessarily see the screen and see who our winners are. Go ahead and record their names. All right, Robert Robinson. Congratulations to our third winner. We're going to announce more winners. Congratulations, Robert. You will be getting a copy of the book. All right, now you're going to go ahead and draw again and find out our second winner here. All right, congratulations, we're going to follow up with you after the session and ensure that you get the copy of the book. But this is I love this. David, you can hear me.
Yeah, there's an echoey thing. Yeah.
Okay, all right. Sorry about the echoey. David, we are at the end of the session, but I would like to wrap up and ask you where can you go to connect you and my details here again. Maybe you wanted to take a minute to let people know where to reach you and what type of consulting you do and consulting training, so we can talk a little bit about that.
Oh yeah, thank you so much. So I mean, for folks, you saw the landing page I created, and on it, as well as other resources, I put a link to my little consulting business, which is called KDM Training, where basically I would like to do more of what I've done for a number of years of doing training, particularly in this sort of scientific and numeric computing space. I have a lot of material that I've delivered to lots of clients, and it slowed down a little bit with COVID, but I would love to have more opportunities, hopefully even to train, groups or organizations in person in the near future, but certainly, anytime I can do it over video, hopefully without technical problems, which always happen. You can take a look at that page, but in general, if you have a need and you want to become more fluent in, any of these kind of scientific computing areas, data science-y kind of things, machine learning kind of things, I would love to teach people. I mean, it's very enjoyable. And in fact, you can check out, I put a link to an upcoming course that I'm doing through, well, it was Brandon Safari Online, now it's just O'Reilly. Although it's Pearson that pays me, it's the interrelationships with these publishers is complex. But anyway, I have a course coming up that on this Monday, so very soon, but I think you can still register, where I'm going to talk about a portion of the material from the book, basically. So it's look at that announcement and you can register for that. And it's a webinar, and then they tend to go pretty well. And it is nice to get feedback in the question area from students, and that's very enjoyable. And then in another month or so after that, I'm doing one that I've done before on scikit-learn and machine learning techniques, and I do this sort of thing recurrently. But I really would love to do more of the kind of stuff that I developed for Anaconda Inc., of doing these intensive 3, 4, 5 day trainings with groups of generally people who have some programming or scientific background, but to bring them to the next level where you can really understand more deeply how to use tools in the scientific computing ecosystem and the design and computational resource considerations and a variety of things like that. Of course, I'd love to teach you the stuff that actually is the material of the book as well, if that's the most relevant to you. But please contact me. I'd love to put together training for folks.
Great, and I'll share the link again. I know you have a webinar coming up that you just mentioned. I'll share the link to your book landing page because that's all that information there. And I am starting to talk the background noise here as well. So that's what's happening with our live stream. But I'm doing this. It's a good time for us, Robin. Maybe I want to thank you so much for being on the Data show. For folks who want to get into cleaning data, one of the most important things you can do with your data. Go ahead
I have one to hold.
There you go. Love it. Very awesome. Thank you so much, everybody, for joining and thank you for participating in our wrap-up along with the winners. Congratulations again, and have a great rest of your day. Bye.
Thank you so much, Cadence. Thank you so much, everybody else on the